Our challenge was to move 200 milliliters of water through 50 centimeters of tubing from one cup to another using 2 solar cells, which were 20 centimeters under a light source.
This was our first design until we innovated it many other times to create this. Our criteria constraints are 20 centimeters below a light source, 750 grams as the weight, 200 milliliters of water, 50 centimeters of tubing, and container at the same level.
We started off our design by placing 3 mirrors on the bottom of a styrofoam plate, and then we placed 2 cups and glued the solar cells to it.
We surrounded our solar cells in 4 different mirrors and angled them different ways to get the best lighting.
To reach our best time, we made sure the tubing was flat and not curved so that the water could move faster through them.
Our solar cells were not working until we separated our wires and taped them separately.
Our best time for moving 200 milliliters of water from one cup to another was 10.36 seconds. NASA told us we had to use 50 centimeters of tubing, and they gave us an extra amount, so we had to cut the tubing to create 50 centimeters.
Bounce off onto
The mirrors helped bounce light from one mirror to another and placing the most amount of light on the solar cells.
The tubing also affected us because if the tubing was flat, the water would pass freely.
We tried to use the lens from the lab once the point, but it did not work. The lens was blocking the light and not allowing enough light to come through.
We also used the technique of angling the mirrors to reflect light from the lab, shed some light, and it proved to be very effective.
We also could have found more ways to focus the light better on the solar cells.
We could have added a stronger motor to pull out, which would have pumped the water out faster, and bigger pipes to help the water travel easier and more at a time. Bigger solar cells would have benefited the project by allowing more light to be transformed into energy.
Some of our struggles included getting the solar cells to work, getting our motor to take in more water, making our tube as smooth and flat as possible to not allow any kinks for the water to get stuck in,